Hi everyone, welcome back to Operations Research. Today we're going to talk about dynamic programming. So dynamic programming obviously is a new topic, and we're going to split the introduction into two parts. The first part is about deterministic dynamic programming. Okay, we will tell you that in a deterministic environment, which means there's no uncertainty. In such an environment, what we mean by dynamic programming and how it is different from integer programming, linear programming, and how it may be applied. And then we will move to stochastic dynamic programming, which is where dynamic programming is really useful. Okay, we're going to do that in today's videos. Okay, so anyway, we need an introduction. So let's start with this very basic example. Suppose there is some guy owns a bakery to bake cheesecakes, and the cost per cake and the demand for cakes are listed below. So in this particular case, all the demands must be satisfied. So here we can see that the demands are 3, 2, 1, and 2. So that means in period 1 or day 1, we need to fulfill a demand for 3 cakes. And tomorrow we need 2 cakes, and then the day after tomorrow we need 1 cake, and so on. And also we have different production costs at different periods. Today, if we make it, it's going to be $4 per cake. Tomorrow it's going to be $6 per cake, and so on. So obviously we need different number of cakes, and the production costs are also different from time to time. So it seems to us that it has some reason for us to produce at those cheaper particular periods, all right? It seems to be okay that today, in day 1, we produce all the number of cakes that we need, and then we store and use them in the future. Seems to be reasonable, but the thing is that if we want to hold a cheesecake in inventory for a day, we're going to spend something. We need to have our refrigerator, we need to spend money, and the cash will create some kind of capital cost. Alright, so anyway, there is a holding cost. So we want to find the optimal production and inventory plan so that we can minimize the total cost and meeting all the future demands, okay? Here we have a figure or a timeline to illustrate what's going to happen in the following 4 days. So we have day 1, day 2, day 3, and day 4. Okay, we have 4 periods. And in each period, the sequence of events is that we're going to first produce something and then sell something. Produce something and sell something, and so on and so on. So this is going to be our timeline, okay? So here, it doesn't really matter what are the numbers, all right? What are the numbers? What really matters is that we are having a situation and we can use a mathematical program to solve it, all right? So it doesn't really matter what the numbers are. Okay, so as we all know, this problem actually can be perfectly solved by linear programming. So this is just a very quick review. We may define xt and yt as the production quantity and ending inventory level for period t, okay? And once we do that, if we call dt as the demand in period t, we're going to have an inventory balancing equation like this. For each period, the initial inventory plus the amount I produce in that period, subtract the amount I sell is going to be my ending inventory, okay? Inventory balancing. And once we have that, just to mention that initially we have nothing, and all the inventory and the production quantities, they should be non-negative. And once we have all of this, we can try to minimize the total amount of production cost plus the holding costs, okay? And here, CT is the production cost per cake in period T. So here, if we want to produce something in period T, we're going to pay CT per cake. And here, YT, in front of YT, there is no coefficient. It's because we assume that the holding inventory, holding cost for inventory is $1, okay? So $1 multiplied YT is just YT. Okay, so I hope this is not too weird for you because this is actually something we talked about when we were talking about linear programming. This is good, but what we're going to do for today is that we're going to introduce how to use another way to deal with this problem. We're going to have some reasons, but anyway, we're going to tell you for dynamic programming approach how we deal with this problem.